Welcome to Geek Do-It-Yourself Mechanic. The purpose of this video is to discuss the typical cooling system in an automobile. So to get there, let's go to Knowledge, Cooling. This diagram depicts a typical cooling system found in an automobile. I say typical in that these are usually all the components that make up a cooling system, but there may be particular implementation nuances in your vehicle. So use this as a reference, but always exactly look up your implementation in your shop manual. So let's begin. I broke the cooling system into three major areas: cooling fans, lubrication system, and then the cooling system itself. Let's start with cooling fans. The cooling fans, there can be one or more. Classically, what we're used to is one big fan driven off the crank. And how that works is a two-part mechanism. One is continuously driven by the crank. As the crank turns, it's spinning this one part of the mechanism. And then there's the clutch that's controlled by the temperature, ambient temperature around it. And when it reaches a certain temperature, it engages, and that engages the fan to the spinning part, which is attached to the crank. So that's what spins that. So that's independently controlled. And then a lot of modern cars, because they're horizontally mounted engines, meaning they're not longitudinal, they need fans. They can't be driven in the front. They need to be, the fans have to be in front of the car, as heading toward the air as the car is driving. So they have electrically driven fans. Those can be controlled two different ways at least. One is they have their own thermostatically controlled switch that when it senses a certain temperature, it engages it. I've seen others where it uses the engine coolant temperature and maybe another temperature sensor where the computer will turn on and off the fan. Either way, look at your particular configuration wiring diagrams to see how you're set up, because that will allow you to debug how, if let's say the fan's not coming on, what's going on. Is it the relay? Is it the sensor? Is it a clutch? If you know what I'm saying. Okay, so let's move on to the lubrication system. This always raises eyebrows when I tell people I consider it part of the cooling system, but in my opinion it is. Oil is being pumped all through the system, first to reduce friction, which reduces heat, and it's just by its nature, it's touching all these, the block and all the friction points, it's going to have heat in it. It's going to withdraw heat into it, hold it, and then as it goes down into the pan, it's going to mix in with the other oil, which is cooler because it's at the bottom of the motor, and dissipate heat into the oil pan. And as air is rushing under the car, it does pull some of that heat from the oil, and then cooler oil at the bottom, if you notice, of the pan is then pumped up through the block. So in my system, it's part of that. And to support that, a lot of times racing cars have larger oil pans. For multiple reasons. First, it's being sloshed around, so they need more of it, and it also helps cooling. Furthermore, some racing applications have a cooler for the oil. Why would they have that if it's not helping cool the overall motor? So in my opinion, it's part of the cooling system. Lastly is the cooling system itself. At a high level, it's comprised of a radiator, hoses, the fan, and some control valves. Let's go into that. So let's talk about coolant. Coolant is very important. So the overall goal of the cooling system is first to raise the boiling point of the coolant. You don't want your coolant to boil. If it boils, it turns to vapor. It does a very poor job at that point of extracting heat from the block. You want it as a liquid. So, to accomplish that, they chemically raise the boiling point by using something we all know as antifreeze. I know it sounds like antifreeze, not to freeze, but it does two things. It makes it so the liquid doesn't freeze if you live in a colder climate, and it raises the boiling point. Won't let it tries its best not to let it go to vapor. Well, depending where you live, it's either 50-50 coolant to water or 70% coolant to water. 50-50 is in warmer areas, 70-1 would be in cooler climates. So, in addition, it also tries to pressurize the cooling system from 15, I believe, to maybe 20 psi. Again, please look it up in your manual, your specifics. But again, if you raise if you put pressure on the fluid, it raises the boiling point. Again, that's the whole goal. So let's go into that. How does it accomplish that? Well, now we know coolant is part of it. Very important. So I suggest never just putting in straight water into your engine if you overheat. Try to get coolant. In addition, I don't use tap water. I use distilled water. There's less particulates in there because of the heat. You possibly reduce the calcium and mineral buildup inside your block and radiator. Just my opinion. Okay, let's go on to the radiator cap. If you remember, I indicated that the cooling system wants to be under pressure to raise its boiling point. Well, the radiator cap helps there. It does two main goals. It keeps pressure in, and then when pressure exceeds that point, again, it's specific to your model, but let's say 18 psi. Once you hit 19, it allows the coolant to go out this flow tube into your overflow tank. And then, conversely, when your cooling system cools down, it allows the coolant to enter back in your cooling system. So it tries to keep your cooling system at a current level. So that's what it does. And now you understand what the overflow container's job is. That's why you feel that needs to be full, because if that's not full and the cooling system is trying to pull in, all it's going to do is suck in air. Bad. You want coolant. You need coolant. Okay, so let's talk about the radiator. His job is to warmer coolant is from the top, and it flows down these little veins, and as air goes through the radiator, it's pulling some of that heat into the atmosphere. And again, the fan is helping, right? It's sucking, it's pulling air through the radiator when you're stuck at a light. And then the fan is also pushing air over the block to, again, also transfer some of that heat into the atmosphere. Back to the radiator. So the radiator, warm fluid is at the top. It drains down on its own by gravity and pressure. It being pushed toward the bottom. We're in hopes that as it's flowing down these veins, the air is rushing through the radiator, pulling heat into the atmosphere from the coolant. Therefore, coolant at the bottom of the radiator should be cooler than at the top. And at the top of the radiator, that should be roughly the temperature of the engine block. So therefore, the coolant at the bottom should be cooler, allowing it to pull heat from the engine block. And then the water pump pushes it up into the block. Classically, the water pump is driven off the crank or the timing belt. I have seen electrically driven water pumps in racing applications. The external radiators of the external water pumps of the classic V8 are much easier to work on than a lot of the four-cylinder cars we drive now, because they tuck the water pump inside the timing belt mechanisms. So usually it's much more costly to change those, because you might as well, while you're in there, change the timing belt, change tensioner, and other things like that. Maybe even do a valve job at the same time. Again, it's application specific, but I just wanted to let you know of that nuance. Again, the water pump pushes the coolant from bottom to top of the engine. And then the thermostat. Thermostat's a valve that's controlled by heat of the block / coolant. The reason it's there at all is when your engine block is cold, it closes, and thereby allowing the engine block to warm up quicker. for two reasons. The car is more fuel efficient when it's at a certain temperature, and when the car is cold, you tend to be less economically efficient. So that's what the thermostat for. Again, that is dependent on application, what temperature that opens up at. But usually maybe 180 to 200 Fahrenheit. Lastly, the heater core. The heater core is literally a mini radiator. It's just like this, but this is inside the driver compartment. Warm coolant, when the driver or passenger turns on the heater, what happens is it opens up this heater control valve that allows coolant, warm coolant, to go into the heater core and return back. So when the blower is turned on inside the car, it's pulling some of that heat from that heater core into the air in the driver compartment, passenger area. That's how the car is warmed up. I'm sorry, the passenger area where you drive, the air is warmed up. So if your car is ever overheating, what I suggest first is you need to pull over. But until you do, turn your heater to full blast and drop all your windows. That will help you cool the cooling system. Lastly, to save yourself a lot of grief and money, if your car is ever getting toward the hot engine driving temperature on your temperature gauge, pull over. The damage that the cooling system, if it's not functioning, your engine can really damage itself. It can be so bad as metal components due to friction seize together, weld themselves together due to the heat. Or because the head is sometimes a different metal, or it's smaller, it's going to handle the heat at a different rate than the block, so it can warp, and that's what classically blows a head gasket. We'll talk about blowing a head gasket later, but that can be quite an expensive repair, into the thousands of dollars. Again, in my opinion, the cooling system is the simplest of all the systems in the car. Very important, and be very attentive to it. Keep the fluids at a good level, keep your coolant as a good ratio, make sure it's good coolant, it's not turning to rust. And if you ever see your gauges not come on, I'm sorry, if you what I was trying to get at, if you ever hear your fans not come on, take care of that. And if your gauges ever get into the overheat range, please pull over. Even that extra block can result in major engine damage. I hope you found this video informative.
Thank you for watching. I hope you found the information helpful.